Questions 11 to 20 of the 1999 Grade 10 Cayley Math Contest. The time on a digital clock is 5:55. How many minutes will pass before the clock next shows a time with all digits identical? Okay, so currently it's 5:55. And of course the next digits would be 666, but of course, as we all know, there's no such time, right? Because you can't have more than 60 minutes. So similarly, 777, 888, 999, all of those are not possible. And then after 9 is, of course, the number 1. But what about 1111? Is that possible? Well, yes. 11 p.m., 11 minutes, definitely. So what we're being asked is how much time between this time and that time. So make it easy for you. Between 5:55 and 6 p.m. we're not really even told if it's a.m. or p.m., but that doesn't matter. That's 5 minutes. And then from 6 p.m. to 11 is 5 hours. And then finally from 11 to 11:11 is 11 minutes. So they want this whole thing in minutes here. So we got to convert the 5 hours to minutes. So 5 times 60 is 300. So the total number of minutes is 5 plus 300 plus 11, which is 316. That's how many minutes pass between 5:55 and 11:11. So the answer is D. The numbers listed here are grouped in pairs so that the sum of each pair is the same. Which number is paired with 15? The best thing to do is to find, first of all, what is the average of this entire list. And that will give us a good indication of the sum. Plus 53, plus 33, plus 13, plus 47. All divided by, how many numbers do we have? 10. And this is 310 divided by 10, which is 31. So that means that the average of this group of 10 numbers is 31. So each pair, if you have a pair, that sum must be 2 times 31, which is 62. That's the only way you're going to get all of these pairs to have an equal sum. So they've told you that in one pair, one of the numbers is 15. So what's the other number? Well, 15 plus this other number has to equal 62. So 15 plus x is 62, and therefore x is equal to 47. So the answer is C. 5 squared plus 1, 5 to the cube plus 1, and 5 to the 23 plus 1. The product, what is the units digit? Units digit means the last digit, the ones digit. And this is a very common question on math contests. So if you have a number 5, 2, 7, 8, 1, 12, 2, like that, the units digit is the very last digit. So I would point to this one right here. Alright, so the 2 would be the units digit in this number. So they've given you this big long number and they're asking what is the units digit. Well, a few of these are pretty easy to figure out. So 5 squared is just 25, plus 1 is 26, and 5 to the power of 3 is 125, so plus 1 is 126, like that. And this one, however, is very, very big. But we won't need to worry about it right now. Save it. 26 times 126 is 3276. And I hope you see that these two numbers had a units digit both of 6, and when you multiply them, the product also has a units digit of 6. So that should give you a little bit of a clue. we certainly don't need to figure out what 5 to the power of 23 is, but one thing is for sure is that we know the units digit of that. It's 5, because 5 to the power of anything will end in 5. For example, 5 to the power of 1 is 5, 5 to the power of 2 is 25, 5 to the power of 3 is 125, and so on. 5 to the power of anything will always end in 5. So 5 to the power of 23 ends in a 5, and then you're adding to that a 1. So this will have a units digit of 6. All right, I hope that makes sense. So if you're multiplying this number by a number that has a units digit of 6, the end result will be a big long number with a units digit of 6. All right, so that's all they're asking for in this question. So 13, the answer is E. In an election for class president, 61 votes are cast by students who are voting to choose one of 4 candidates. Each student must vote for only one candidate. The candidate with the highest number of votes is the winner. The smallest number of votes the winner can receive is. All right, so there's 61 total votes. And what's the smallest that the winner can receive? So if you divide 61 by 4 evenly, you'll get 15.25 for each. But obviously you can't have 0.25 of a vote. But you can have 15, 15, 15, and 15, and there's one more vote left because this totals 60. So if one of these candidates gets that 61st vote, see right now it's a 4-way tie. If one of those candidates gets that last vote, that candidate will go up to 16. And this candidate will therefore win the election. And mathematically, this is the smallest number of votes that a winner can receive. So the answer for 14 is B. A chocolate drink is 6% pure chocolate by volume. If 10 liters of pure milk are added to 50 liters of this drink, the percentage of chocolate in the new drink is. All right, so initially we have a drink and they tell you 50 liters. And of this, 6% is chocolate. So that means 0.6 times 50 liters is the chocolate component. So that's 3. Now they're adding an additional 10 liters of milk. And they want to know, when you do that, how much is chocolate? What percent? So in our new mixture, we have 10 plus 50, a total of 60 liters of drink. And the chocolate content is still the same, it's 3. All right, so now what is the percentage of the chocolate? So 3 over 60 is 0.05, which is 5%. So the answer is A. 3 circles, each with radius 10, are drawn tangent to each other so that their centers are all in a straight line. These circles are inscribed in a rectangle, which is inscribed in another circle. The area of the largest circle is. So let's draw this out a little bit bigger. All right, so here we go. It's not perfect, but you get the idea. So let's start labeling these now. We've got 3 circles, and each of them has a radius of 10. So if we were to draw any of these radiuses, it would be 10 like that. Okay? And they're all in a straight line. The radiuses match up like that. And this is also 10 like that. And the radius of the large circle will be from the center point to here. We'll call that R, like that. And then from here to here, we know is the same as from here to here, the top part, and that is 10 and 10. So this is 30. And therefore, if you look at that triangle, this one right here, we can get a relationship from Pythagoras. So that would be 10 squared plus 30 squared is equal to r squared, like that. So this looks like 100 plus 900 is equal to r squared, and therefore r is equal to the root of 1000. The question is asking the area of the largest circle, so that would be pi r squared. Pi r is square root of 1000 squared, and therefore this is just 1000 pi. So 16, the answer is A. Let n be the smallest positive integer whose digits have a product of 2000. The sum of the digits of n is. So let's explain this question first. Let's say you have an integer 2, 1, 3, 8. And they're asking you, first of all, what is the product of the digits? Well, the product of the digits is going to be 2 times 1 times 3 times 8, right? Which in this case is 48. And if I ask you the sum of the digits, what would be the answer? Well, it would be 2 plus 1 plus 3 plus 8, which looks like 14. So just in case you were a little confused with that, that's what the question means. Now they're telling you, let's look at the question, that n is some number. We don't know how many digits it is. I wish they had told us, but we don't know. And if you take the individual digits, A, B, C, D, E, and you multiply them, A times B times C times D times E, like that, it would be 2000. They want you to find the sum. So they want you to find A plus B plus C plus D plus E. All right? So how do you do this? Well, the first thing we need to do is look at the number 2000 and break it up into its prime factors. So that would be 2 times 2 times 2 times 2, I believe. And then that's 8, so that's going to give you 125 remaining, which is 5 times 5 times 5. All right, now, is this a number that has a product equal to 2000 with respect to its digits? And the answer is yes. These are the prime factors. So is this the number that they're looking for? Well, no, because they want you to find the smallest positive integer. And this is a huge number. It's 2,222,555. So can we find a smaller number? Well, I think we can. We can group some of these together. Like, for example, if we group that together, we'll get an 8. And if we leave that by itself, because if we start multiplying anything else, it'll give us a 2-digit number, and we can't put that. So we have to leave everything else the way it is. Because if I tried to combine 5 and 5, that becomes 25, and 25 is not a digit. It's a 2-digit number. It's not a single digit. So I've come to this. Now let's verify the product of the digits. Is that equal to 2000? 2 times 8 times 5 times 5 times 5. Yes, it is 2000. And if you look at this carefully, you realize that this is the smallest that you're going to get. So now we just have to find the sum of the digits. So the sum of the digits of this, n, are 2 plus 8 plus 5 plus 5 plus 5 which is 25. So the answer to number 17 is C. A cylindrical pail containing water drains into a cylindrical tub. So this is the pail, and this is the tub right here. The tub is 40 centimeters across and 50 centimeters deep, while resting at an angle of 45 degrees to the horizontal as shown. How deep is the water in the tub when its level reaches the pail? So when the water reaches the level of the pail, they want you to find that. All right, so let's draw this a little bit bigger. So this is our diagram, and I'll start labeling things now. This is 45 degrees, as they told you. And if that's 45 degrees, then since this is a vertically opposite angle, that will also be 45. And therefore, this is a cylinder. It's in the shape of a rectangle. So this is 90 degrees right here. And this is 45, which makes perfect sense because all the angles add up to 180. Now what else can we label? This is also 90. This is also 90. And this is 45. This is also 45 degrees. And same thing here, 45, 45. And this blue line that I wrote right there is the level of the water. All right? And all of this in here is water. And then we're going to have to label a few other things. This from here to here is what they want us to figure out. So I'll call that H, height. And from here to here, from the top till this point, I will call that X. And then the total, we know, is 50. That's been given to us in the question. And then the top here, from here to here, is also something we know. It's 40 centimeters. And that should be enough to figure out H, which is what they want. All right, so where do we go from here? Well, we can use this triangle right here, this one. It's a right triangle, so we can use that to figure out one of these sides. So from here to here, I will call that Y. And because these two angles are the same, the distance from here to here is also the same, so that is also Y. Y squared plus Y squared is equal to 40 squared. 2Y squared is equal to 1600. Y squared is equal to 800, and therefore Y is equal to the square root of 800. All right? So now let's move this up. Now, what else can we calculate? Well, we can figure out H, because if from here to here is H, and these two angles are the same, that means this is also H, because it's an isosceles triangle. So then we can use this triangle and the Pythagorean theorem. So this time we have x squared plus x squared is equal to y squared. So 2x squared is equal to y squared, and y squared is 800. So therefore x squared is equal to 400, and x is equal to 20. And then finally, to figure out h, remember x plus h is equal to 50. So x is 20. And then therefore you can just solve for h. H is going to be 50 minus 20, which is 30. So the answer to number 18 is 30, which is C. A number E is Bipresque if it is the only natural number between a prime number and a perfect square. For example, 10 is Bpresque, but 12 is not. The number of two-digit Bpresque numbers is... Okay, first we need to understand what are they asking. So I'll give you an example, which they already did, but let's talk about it a little bit more. Let's say you have a prime number, like 11. Okay, this is a prime number. And then you have a perfect square, such as 9. The first thing they want you to check is, are there any natural numbers, any integers, in between those two? And in our case, there is. It's the number 10. Now, because the number 10 is the only natural number between a prime and a perfect square, it will be called a Bpresque number. Does that make sense? I hope so. So let's move forward. The first thing is we are only interested in two-digit Bpresque numbers, right? So we only need to worry about numbers between 10 and 99. Two-digit. So the first thing I'm going to do is write out all the perfect squares from 9 to 100 to cover this range. So we've got 9, 16, 25, 36, 49, 64, 81, and 100. I think that's it, right? 3, 4, 5, 6, 7, 8, 9, 10. All right. So now we have to write out the primes. And unfortunately, this is one of those questions where you had to have memorized all the prime numbers until 100. Oh boy. So we've got 11, 13. We've got 17, 19, and 23. Then we have 29 and 31. Then we have 37, 41, 43, and 47. 53 and 59. 67, 71, 73, and 79. And finally 83, 89, and 97. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. There's one missing in here, 61. Sorry about that. All right, so here we go. Now we can move forward. So we now need to basically figure out this type of scenario anywhere throughout this question. Well, let's start here. 9 and 11. 9 is a perfect square, 11 is a prime, and we already know that 10 is a Bpresque number. It's the only number between a perfect square and a prime. Let's go to the next one, 13 and 16. Well, there's two numbers between 13 and 16, so we don't have a single natural number. 16 and 17, well, there's nothing in between there that's a integer because those are consecutive. 23 and 25, there you go. You got 24 as your only number between a perfect square and a prime. So we have two now. 25 and 29, that won't work because you got more than one number in between. 31 and 37, same story. 36 and 37, no numbers in between there. 47 and 49, yes indeed. We have 48, and therefore that is Bpresque. 49 and 53, more than one number. 64 and 61, same thing. 64, 67, same thing. But 79 and 81, there's only one number in between there. 79, of course, being our prime, and 81 being our perfect square. And then the next one, we get another one, 82. Because 81 is our perfect square, and 83 is our prime. And that's it. 97 and 100 have more than one number. So we got 10, we have 24, 48, 80, and 82. We have 5 two-digit Bpresque numbers. So 19 is E. The area of the given quadrilateral is, okay, this diagram is sufficiently large for me to just work with it. I'm going to cut it like that. And immediately, before I move forward, I'll just calculate the area of this triangle. 1/2 base times height. So 1/2 base is 1, height is 1, so we got a half. All right, so that part, no problem. Now, how do I figure out the area of this shape here? Well, I'm going to draw a perpendicular like that to that base, and therefore, because it's a perpendicular, it's a right triangle. All right? And we're going to do a little bit of labeling here. From here to here, I'm going to call that B, and from here to here, that's also B, because this line cut it in half. And this line I'm going to call H. All right? Now let's move forward with this. Now to figure out B, I'm going to actually use this triangle. So use Pythagoras, you get 1 squared plus 1 squared equals 2b all squared. So 1 plus 1 is 4b squared, and therefore 2 over 4 is b squared, and therefore b is the root 2 over 2. Okay? Now H, same thing, we can use any of these triangles, this one for example, to figure out H, because this is a right angle. So we have H squared plus B squared is equal to root 5 squared. So H is what we're trying to figure out. B squared is right here. It's 2 over 4, or 1/2. And then root 5 squared is just 5. So H squared is going to be 5 minus 1/2, which is 9 over 2. And therefore, H is going to be 3 over root 2, like that. And then therefore, now we can figure out the area of this shape. It's a triangle. 1/2 base times height. 1/2, the base is 2b. And the height is H. So the base, 2b, what's b here? Root 2 over 2, right? So 2b would be just root 2. And H is right here, root 3 over 2. 3 over root 2. I'm getting confused there. So this looks like just 3 over 2. All right, now be careful here. Don't jump and choose A, because that is just the area of this guy. We have to find the area of the whole thing. Don't forget about the half there. So the area of the total is the area of that triangle and the area of that triangle. So 3 over 2 plus 1/2, which is 2. So the answer is not A, it's D.